Welcome to the high-energy heart of analytical science. In our last unit, we were gentle. We gave wings to molecular elephants with ESI, preserving delicate structures. But today, the strategy changes completely. Imagine you aren't looking for a massive protein. Imagine you are looking for one single atom of lead or arsenic, hidden in a billion liters of water. To find that needle in a global haystack, we must leave the gentle mist and step into the fire. Welcome to the chemical inferno, ICP-MS. Have you ever felt like your background noise was hiding a real threat? To see the elemental truth, you must be willing to destroy the form. We are going to learn how to rip matter into its atomic components using heat hotter than the surface of the sun, achieving precision at the part per trillion (ppt) level. This is the ultimate truth seeker for environmental and clinical safety. Today we navigate 4 strategic sectors. Sector A, the 10,000 K gate, why brutal ionization is the only path to elemental truth. Sector B, the sorter and the storm, navigating the interface from fire to vacuum. Sector C, the ROI of PPT, understanding the accountability of detecting 1 cent in $10 billion. And Sector D, isotopic fingerprinting, the specialist's secret for tracing the origin of pollution. The difference between an amateur and a pro is knowing that you can't see the element until the molecule is dead. In ICP-MS, we use an inductively coupled plasma torch. We take argon gas and ignite it with a radiofrequency field. We aren't just heating the sample. We are creating a plasma at 6,000 to 10,000 Kelvin. At these temperatures, every chemical bond is erased. The elephant is being vaporized into its base atoms. Look at the entry path. Your sample starts as a liquid. It is turned into a fine mist via nebulization, but only about 1% to 2% is fine enough to enter the torch. Once inside, droplets undergo desolvation, vaporization, atomization, and finally, ionization. We aren't preserving biology here. We are reducing nature to its periodic table basics. By the time the sample leaves the torch, it is a stream of pure positive ions. Now we face a massive physical challenge. The plasma is at atmospheric pressure and 10,000 K. The mass analyzer is in a cold, high vacuum. How do we bridge that gap? We use the interface cones. Imagine a tornado that perfectly sorts different colors of sand. Your ions must pass through a sampler cone and then a skimmer cone. As a specialist, you monitor these cones religiously. If they foul with salt, your 10,000 K signal drops to a whisper. Once inside the vacuum, we use a quadrupole to sort the atoms. But beware, the inferno creates ghosts. Argon can combine with oxygen from your solvent to create ARO+, which weighs exactly 56, the same as iron. Mentor's tip. Actually, the pro knows that interference management is the real battle. We use collision cells filled with helium to bump these polyatomic ghosts out of the way, leaving only the atomic truth. Why does part per trillion matter? Think about the accountability. Detecting 1 ppt is like finding 1 specific cent in a pile of $10 billion. In the semiconductor industry, a single ppb of metal impurity can ruin $1 million wafer. In clinical pathology, we monitor selenium, zinc, and manganese to ensure health. This 8-order dynamic range is your laboratory insurance policy. Here is the consultant's secret. ICP-MS doesn't just tell you how much, it tells you from where. Because we can measure isotopic ratios with incredible precision, we can use isotopes as a chemical GPS. Lead from a mine in Australia has a different signature than Peru. We use this to trace the origin of pollution or provide forensic evidence. You aren't just counting atoms, you are reading history. Have you ever felt like you were just a button pusher? In ICP-MS, you are a truth seeker. You are the one who ensures the water is safe, the chips are pure, and the diagnosis is correct. You have moved beyond fragments and into the atomic core. By mastering the inferno, you have silenced the matrix and found the ghost that everyone else missed. Summary. Mastery of the inferno. We've moved from the wings of the elephant to the fire of the torch. You now understand the deconstruction logic of 10,000 K plasma, the physics of the interface cones, and the strategic power of isotopic fingerprinting. Precision isn't a setting, it's a deconstruction strategy. Silence the noise to see the truth. You've mastered the bulk atoms. You can find a needle in the ocean. But what if the truth isn't in the liquid? What if it's hidden on the surface of a solid, layer by microscopic layer? Join me in our next unit, Module 6-3, Surface Sputtering, where we leverage SIMS for high-sensitivity depth profiling. I'll see you there. Any final questions on the 10,000 K gate before we move to the surface?